Okay. Hi all. I am Ravina. Now we are going to study about the second chapter of our science class chemistry, that is acids and bases. Okay. So you all know what is acid and what is base, as we already studied in our previous classes. What is the how can we identify an acid and a base? What is the taste of an acid and base? What are the common constituents present in an acid and base? And you also know about vinegar, isn't it? Vinegar is also an acid. So today we're going to discuss more about acids and bases based on our NCERT textbook. Okay, so without losing much time, we just going to see what all are the content in our um session. Okay, so So I'm going to introduce this chapter with an index question that is which is represented in our page number 18 of your textbook. That is, you have been provided with three test tubes, which means you are provided with three test tubes. One of them contains distilled water, and the other two contain an acidic solution and a basic solution. Okay, the acidic solution means it's directly not an acid, but the acid which is dissolved in water. Okay, that is what is called acidic solution, which is very dilute. Okay, and the other one is basic solution, that means a base is dissolved in water. Okay, so you are provided with the three test tubes, and in each test tube you are provided with the distilled water, acidic solution, and a basic solution. Here, if you're given, and you also given red litmus paper. Okay, so red litmus paper, how will you identify the contents of each test tube? So that is the task assigned to you. That is, you need to identify the contents which is present in each test tube, whether it is distilled water, whether it is acidic solution, or whether it is basic solution. That is your task. So before going to that, I'm just showing you, this is litmus paper. Okay, this is a red litmus paper, and this is the blue litmus paper, and this is the red litmus paper. This litmus paper is an example for natural indicator. Okay, it is collected from some types of lichen. Okay, you already made litmus paper in your previous classes by using hibiscus, isn't it? So the hibiscus, while we are rubbing this hibiscus on a white paper, you will get this blue litmus paper, and by using this blue litmus paper, we can identify where the given solution is acid or base. But in current situation, here you are provided with a red litmus paper, that is this red litmus paper. You are provided with a red litmus paper, and you need to identify whether the given solution in each of three test tubes, whether it is acid, whether it is base, or whether it is distilled water. Okay, so first of all, okay, what we can do? Okay, first of all, take the first test tube. Okay, and you are going to dip this red litmus paper into the first test tube containing the solution, and you don't have any idea about whether it is distilled water, whether it is acid, or whether it is base. Or you are just dipping this red litmus paper into the test tube, and you can see if the inference is, you can see a slight color change, that is this blue litmus paper just changes its color to purple color, or whether it changes to blue color, or whether it can be there is no change in the color. Okay, okay, so these are the three inference you will get when you dip this red litmus paper into the test tube. And if the inference is sorry, and if the inference is just a little color change. Okay, you're just going to dip this red litmus paper to the first test tube. Okay, the inference, these are three inference, that is whether this red litmus paper just changes its color to just a light shade, that is purple color, or it can be changed its color to the blue litmus paper. And also the third inference is there is no color change. Okay, so you are now dipping your red litmus paper to the solution, and you can see uh, if the color of the red litmus paper just changes. Okay, just changes. Red litmus, the color of the red litmus paper just changes its color to a purple color. A slight change in the color, as because the purple just goes on wetting. Okay, it is due to some wetting. Okay, if the red litmus paper changes the color to the purple, and if it is that's just because of the wetting, then it can be written as that is distilled water. Okay, that is, we can directly say that it is distilled water. And the color of the red litmus, okay, we are dipping this red litmus paper to the second test tube. You can see the red litmus paper changes color to the blue, or then we can write it as base. Okay, you can see here B and B, that means here B rule, that is base is always blue in color. Okay, and if the red litmus paper doesn't change its color, okay, red litmus paper and it doesn't change its color, no change, then we can say that it is an acid. Okay, then this change say, then we can say that it is an acid. So these are the inference. Okay, these are the inference we get while we are doing this experiment. Okay, so that means you are providing three test tubes with a distilled solution, acidic solution and basic solution, and also you are provided with the red litmus paper. Okay, so the red litmus paper, while we are dipping this red litmus paper to the solution, and if the color just changes from to the purple, that is because of wetting process, then it can be said that the solution is distilled water. And also the red litmus paper just changes its color to blue, then we can say that is base. You all of you please note on that B rule, that is base is always in blue in color. Okay, that means base, if we dip a blue litmus solution, it retains its color, that is blue. And if we are, this is base, okay, this is the litmus paper, okay, and this is the color. Okay, so base, we are dipping this blue litmus paper to base, the color will be blue. And this is a base, and if you are dipping a red litmus paper, and you will get the color as blue. That means base always be blue in color. So red litmus paper, a red litmus, we are dipping this red litmus to this third test tube. You will, if there is no change, then we can say that it is an acid. Okay, clear. Okay, so let's see what is the correct. Okay, how can we answer this question? How can we answer this question? The correct answer is, if the color of the red litmus does not change, then it is acid. And if the color of the solution, uh, how the color of the red litmus changes to blue, then it is a base. And if there is a slight change in the color of the red litmus, such as purple, that is just because of the wetting process, then it is distilled water. Clear. So that is the correct inference of the activity, which is depicted in page number 18, that is the in-text question. And from this we can just get into our chapter, that is acid and base. Okay, so here we are discussing about what is acid and what is base. Okay, so that is activity 2.1. You're going to see this is activity 2.1, and here you are provided with the hydrochloric acid. You can see this is hydrochloric acid, okay, HCl, then sulfuric acid, that is H2SO4, okay, sulfuric acid, nitric acid, that is HNO3, acetic acid, that is CH3COOH, sodium hydroxide, that is NaOH, calcium hydroxide, that is CaOH twice, potassium hydroxide, that is KOH, magnesium hydroxide, that is MgOH twice, and the last ammonium hydroxide, that is MnH4OH. Okay, and also you are provided with the red litmus solution. Okay, these are the four things here. I just give to you, that is red litmus solution, that is blue litmus solution, that is the second one, phenolphthalein, that is the third one, and methyl orange, that is the fourth one. Okay, so this red litmus solution and blue litmus solution are natural indicators, as you all know that the natural indicator. The phenolphthalein and methyl orange are not natural indicators, they are just indicators. Okay, so now the sample solution which is provided is this. So now I am taking this hydrochloric acid, that is HCl, and now I am going to add the red litmus solution to the hydrochloric acid. What will be the inference, or what is the change you can see there? Since this is an acid, that is HCl, since this is an acid, so the red litmus solution, there is no change. We cannot see a change there because it is an acid solution, that is, which means red litmus solution regains its color. Okay, the second one is I'm going to add some blue litmus solution to the hydrochloric acid. If the color of the hydrochloric acid, blue litmus solution changes to red. Okay, and now I'm adding this phenolphthalein solution. Okay, you can see here, this is the phenolphthalein. Okay, this is the phenolphthalein, the change of phenolphthalein in the acidic condition and in the basic condition. You can see here in the acidic condition, that means up to pH 7. You can see here that is colorless, which means it is completely colorless. The color of the phenolphthalein is absolutely, it is transparent. There is no color. You can see here, this is the color change. Okay, moving from acidic to basic nature, that is from pH is 7 to 11. That means in 8 to 11, you can see there is a slight color change to pink color, clear. So the pH in the basic condition, it exhibits a color, pink color, and in acidic condition it acts as colorless. Okay, so here I am taking this hydrochloric acid as a sample solution. So the phenolphthalein, the color of phenolphthalein will be okay. So as we already said that this pH, the color of the pH, okay, you can see here the pH, the phenolphthalein, the color of the phenolphthalein in acidic condition is colorless, and in basic condition it is pink color. Okay. Okay. Okay, so while I'm adding some phenolphthalein solution to hydrochloric acid, what will be the inference, or what is the observation you can see there is phenolphthalein solution, it is colorless itself. There is no change. Phenolphthalein is colorless, and in acidic solution it regains its property, that is colorless. At the same time, I'm going to add some methyl orange solution to hydrochloric acid. Okay, I'm going to add some methyl orange solution to hydrochloric acid. You can see here, this is the color change of methyl orange. Okay, this is the color change of methyl orange. Here in acidic condition, it exhibits a red orange color shade. You can see here, this is a red orange color shade, and in the basic condition you can see here that is a yellow colored solution. Okay, so in basic solution, methyl orange just changes its color towards yellow, and in acidic condition if the color is red orange color. Okay, so here the sample solution is hydrochloric acid, therefore methyl orange solution. What is the color of the methyl orange? The color of the methyl orange is red color or red orange color. Okay, red orange color. Okay, so now we are taking the sample as sulfuric acid, that is H2SO4. Since it is an acid, the red litmus solution, there is no change. Okay, there is no change. And blue litmus solution, since this is also an acid, blue color changes to red. Phenolphthalein, there is no change in its color of the phenolphthalein. Methyl orange solution, it's also red orange color. And moving to this nitric acid, that is HNO3. Okay, HNO3. Since it is an acid, red litmus solution, there is no change. Blue litmus solution changes its color to red. Phenolphthalein colorless, and methyl orange solution, that is red color itself. Okay, and let's see what is other samples. So why we are taking the sample solution as acetic acid? Okay, red litmus solution, there is no change since it's an acid, and blue litmus solution changes its color to red, and phenolphthalein solution, it is colorless again, and methyl orange solution, it is red color. Calcium hydroxide and KOH, magnesium hydroxide and ammonium hydroxide, you can see here the presence of OH minus ion. So this OH minus ion makes it a base. Okay, presence of this OH minus ion makes it as a base. So the red litmus solution changes its color to blue since it's base BB rule. Okay, and the blue litmus solution, there is no change. You can see there is no change. And the phenolphthalein solution, as we already said, that pink color, it exhibits the color of pink since these are base. The samples are base, therefore the phenolphthalein solution, it changes its color from colorless to pink. It exhibits the pink color here since these are base. Okay, the methyl orange, okay, and also methyl orange, it changes its color from red to yellow. So the basic solution, methyl orange shows yellow color. And the case of ammonium hydroxide, you can see here this ammonium hydroxide, the pink color of the phenolphthalein solution. Okay, while we are adding some phenolphthalein solution to ammonium hydroxide, as ammonium hydroxide is a base, it indicates some color, that is pink color, and this pink color becomes colorless after some time. And also the methyl orange solution, when we are adding some methyl orange solution to ammonium hydroxide, the yellow color which forms becomes colorless after some time. Clear? Okay, so the next activity which is in your textbook is about olfactory indicators. What is this olfactory indicators is? Olfactory indicators are the indicators which can be used. These are indicators. There we can identify whether it is an acid or a base by using the smell. We can identify whether it is an acid or base by using smell. Okay, so the activity for olfactory indicators and natural indicators, that is our second activity, that is activity 2.2. Here example 1 is cloth strip. Okay, that is I am taking a cloth strip and I'm kept it in a bag with a finely chopped onion, or I am wrapping a finely chopped onion. Okay, I'm going to wrap a finely chopped onion with a cloth strip. Okay, and left overnight in the fridge. The strips would smell of onions. So obviously the strips would smell onion. Clear? After this, okay, I put it in the fridge for overnight and I take the cloth strip in the next morning, and now I'm going to add some dilute hydrochloric acid. Okay, I'm adding some dilute hydrochloric acid. Okay, I'm adding some dilute hydrochloric acid. What is the inference there is? Smell of the onion regains. Okay, smell of the onion is there, and also the red color of the strips changes to pale red. Red color changes to a pale red. Okay, red color of the cloth strip just changes to pale red. Similarly, here I am adding acid. Okay, the cloth strip. Okay, cloth strip is added with the acid. Okay, or I am adding some acid to cloth strip. Now I am going to add a base. Okay, now I am going to add some base. Okay, the cloth strip, I'm going to add a base, that is sodium hydroxide solution is a base. And what happens here, red color just changes to green color. Okay, red color changes to green color. Red color changes to green color. Okay, so that is the activity 2.2, which means by using this olfactory indicators, okay, by using these olfactory indicators, we can identify whether it is an acid or a base. By here onion is taken as the olfactory indicator. We are wrapped this onion and kept it in the fridge for an overnight, and obviously after in the next morning when we take this cloth strip, it will smells onion. Okay, and this cloth strip I'm going to add some dilute hydrochloric acid or acid, any acid I'm adding. Then what happens here, the red color of the cloth strip just changes to pale red or okay, pink color. And also I'm adding, if I'm adding some dilute hydrochloric acid or dilute sodium hydroxide or a basic solution I'm going to add to the cloth strip, the red color of the cloth strip changes to green. From this inference, we can identify or we can classify whether it is, and we can separate whether it is an acid or a base. Okay. The example 2 is another odor test, another one odor test. Okay. Here, a vanilla essence, as we all know that vanilla essence for baking cake and all the baking purposes, we are using this vanilla essence for making biryani, and all we are using this vanilla essence, and all thing I think in every house there is vanilla essence. Okay, this vanilla essence, I'm taking this vanilla essence to dilute hydrochloric acid. Okay, I'm adding some dilute hydrochloric acid to vanilla essence. Smell of vanilla essence exists. Or otherwise, you can ask citric acid. Okay, citric acid, which is present in lemon juice. Okay, that is lemon juice. An example for acid, or we can use acetic acid, that is our vinegar. Okay, vinegar. You can ask any acid, you can add any acid to the vanilla essence. Okay, you can add any essence, add any acid to vanilla essence. The smell of vanilla essence exists. But you're going to add some dilute sodium hydroxide solution, that is a base. You can see in your house you will get some sodium bicarbonate solution, or similarly basic solution. Okay, that is sodium hydroxide solution itself, that means our soap powder. Okay, now you're going to add some soap powder in your vanilla essence, then the smell, it goes off, or there is no smell. That is another one example using this vanilla essence, and the one is some clove oil, similar, same experience, that is clove oil, that is our grambu. Okay, grambu, in Malayalam it is grambu. And here clove oil, I am going to add some dilute hydrochloric acid to clove oil. You will get that the smell of the clove exists, same acid, smell persist, smell retains. Okay, in acid smell retains, and in base no smell. Okay, in base there is no smell. Okay, that is activity 2.2. Okay. Okay, so what we are going to see is how do acids and bases react with methods. Okay, so I will show you. Okay, unfortunately I couldn't show this video. Okay, I will post it in the description box about what is this, what is happening here, or what is this video. Okay, okay. So this is the pictorial representation, as we already discussed. This is the pictorial representation. This is the burning of hydrogen gas with pop sound. Okay. So here the reaction between acid and metal, here what happens is, okay, when zinc react with dilute hydrochloric acid, okay, where zinc react with dilute hydrochloric acid, we know here zinc is taken here, and we are adding H2SO4. This is an example for single displacement reaction. You already know that what is the single displacement reaction in your previous chapter, you already studied. Here this sulfate ion HSO4 2 minus, SO4 2 minus is a polyatomic anion. Okay, this polyatomic anion displaces its place towards zinc. Okay, displaces its place towards zinc. Okay, and formation of zinc sulfate and H2 along with H2. This is the gas here that is evolving out, that is H2 is evolving out. This is the gas. So that is happening here is in this reaction, the zinc when react with the sulfuric acid, that is zinc when react with the sulfuric acid, that is dilute H2SO4, what happens here is there is a single displacement reaction, displaces of this sulfate polyatomic anion towards the zinc and forms zinc sulfate along with the hydrogen gas. Here in this slide I took dilute hydrochloric acid, and here the reaction is zinc when react with the dilute hydrochloric acid, same, that is single displacement reaction, that is single displacement reaction. It is similarly, it is same as that is displacement reaction, that is nothing but this displacement reaction. Here zinc chloride, the chloride ion just displaces its place towards the zinc, okay, and forms zinc chloride plus H2 along with the heat. This is an example. This is an exothermic reaction. You already studied about exothermic reaction in your previous chapter. So this is an exothermic reaction, which means liberation of heat here. So the inferences are hydrogen gas is formed. The gas formed here is hydrogen gas. On passing hydrogen gas evolved through a soap solution, bubbles are formed. So due to this evolution of hydrogen gases, bubbles are formed in the soap solution. Okay, and a burning candle near gas-filled bubbles causes a pop sound. And it's due to the presence of this hydrogen gas. Okay, the If we show some burning candle near the gas filled bubbles, it causes a pop-up sound, or it breaks the bubble breaks with the pop sound. Clear? Okay. So I think we need to conclude it now. Bye bye. See you in next video. And if this video is helpful, please like, comment, and share. Thank you.